In this video, we're going to look at Agarose Gel Electrophoresisa. So imagine you have your DNA sample from last week that you isolated and you want to examine it. Well, one way we can do that, in addition to the UV spectrometry, is via Agarose Gel Electrophoresisa. And this will tell us, or we can use this technique to determine the integrity of our sample. We can work out the size of a piece of DNA that we wouldn't know at that stage, and we can isolate a piece of DNA that might be in a mixture. So effectively, if we start with our sample here and we say, well, the sample contains pieces of DNA that are, say, small double-stranded molecules, medium double-stranded and large double-stranded DNA molecules. And if we want to separate these based on size and maybe determine the fragment of a particular size, we can do that using this technique. And the unit that we measure DNA in now is the length of DNA, so that's the amount of base pairs, or BP. You'll see that in lots of text. So we're going to get a particular powder called agarose that we've isolated from seaweed, and we mix it with a liquid buffer 1-XT-AE, tris-acetic acid, EDTA. And we then heat that before adding some CyberSafe, and this is a particular chemical which will help us visualize the DNA under UV light later on. We then pour the gel into a casting apparatus and we add in a comb to give us wells before letting that set, and then we can move on to preparing our samples. So effectively, if you got this gel and actually looked at what it's composed of, if you could see, it's like a mesh. So we're going to get our samples into a well and push them through a mesh, and the smaller bit of fragments should get through the mesh from one end of the gel to the other faster than large ones that would be impeded. So if we take this piece of our sample, we'll say it had small, medium, large, and we pipette it into a particular well, we can actually try to separate these. So imagine on the right hand side here, we load our 4 lanes. Once we add a particular current, our DNA is going to move through the gel. Now I want you to think, is there a reason you could tell why it moves towards the positive, something that we covered in a previous video? Well, effectively, DNA is always negatively charged because of the phosphate groups, and that means it will always migrate towards the positive. And here, smaller pieces of DNA will get through the mesh faster than medium, which will be faster again than larger ones, which will be impeded a little bit. So we can separate them based on their size. So here in this experiment, if we load in the first lane a marker, so this would be a piece of DNA that we know the sizes of, provided to us by a manufacturer. And say in lane 3 we have one piece of DNA and we don't know the size of that. So we can load in those samples and we're going to electrophorese them through the agarose gel. When the gel is finished, we might see these little, kind of with our eyes in normal light, we'll see these little blue stains. This is our tracking dye. Lets us know that the gel hasn't ran too far and the samples haven't ran off the bottom of the gel. But if we add UV light, it allows the CyberSafe mentioned earlier to fluoresce, and that gives us an idea of the DNA. So when we add UV light, this is what we'd see. In the first lane, these are pieces of DNA that we know the sizes of. So you can imagine this might be 100 base pairs, 200, 300, 400, 500, so on, 600. It depends on the marker that you use. And lane 3 was our unknown sample. But we now know that this has traveled the same distance as the 300 base pair band here. So we can predict that this is approximately 300 base pairs in length, this fragment of DNA. So electrophoresis can be used for us to size pieces of DNA that we need to know. So it's a superb technique. It's one that you'll readily use. We can determine the integrity, see if samples are denatured or smears, or if they're sharp bands. We can size a piece of DNA. And if we want to isolate it, we can even cut a piece of DNA out of the gel for future use.